Greetings and welcome to the video on hypotheses. In addition to what we already have on the board, let me go ahead and get this up on our canvas. So we're going to leave this up. We're going to draw from this, and we're going to talk about the different types of research hypotheses. Okay, so building off of this previous example, what did we have? We were asking the research question, does this drug X, and this drug was albuterol, have an effect on the observed outcome? We said, what is the outcome? Well, it's this forced expiratory volume measure here. And we randomly assign individuals into the getting the albuterol here in this top row, right here. And then we randomly assign some folks to get a placebo down here in this one. And at the end of the day, what we wanted to do is we wanted to compare the mean of the first observation here, the albuterol group, to the mean of the placebo, or the second observation. And so what are the possible outcomes that we can have here? So we could say one outcome is that O1 is greater than the mean of O2. We could also say that O1 might be less than the mean of O2 after the intervention, or the X. And another option would be is that O1 is equal to O2. So the point here is that in kind of this grouping, what I've done for you is basically saying that the drug has some kind of effect. And over here, what are we saying? We're saying the drug has no effect, right? If the drug is causing the mean of O1 to be greater than that of the placebo, it's having an effect. If it's causing it to have a mean below that of the placebo, it's still having some type of effect. But if the mean of the O1 group is equal to the mean of the O2 group, that's basically saying the mean of the albuterol, the treatment group, is equal to the mean of the placebo group, then the drug has no effect. So the point of the story here is that when we're talking about research hypotheses, either the drug is going to have an effect or not have an effect. And these outcomes are contradictory, right? An effect versus no effect. They're contradictory. They're binary. Having an effect is a 1, a no effect is a 0. They're binary. They're mutually exclusive. Both cannot be simultaneously true. The drug cannot both have an effect and not have an effect at the same time. So when we're talking about the world of hypotheses, and how we use statistics to test these hypotheses, we have to take one of these hypotheses, either it's going to have an effect or it's not going to have an effect, and we have to hold on to one of those to test it. And the one that traditionally, by convention, that we hold on to be true is the no effect case. And what do we call that? We call that the null hypothesis. So the first thing we're going to talk about here is the null hypothesis. This is the hypothesis of no effect. This is the one we test. It can take on a written form. So what's an example here? We use, by the way, for null hypothesis, the nomenclature H sub naught or sub 0. So an example of a written null hypothesis based off our design above is drug X will have no effect on the outcome. pretty self-explanatory. It's just written out. That's exactly what we're saying up here. The drug has no effect. We're just making it in written form. But if we don't actually test the written form, we're testing the statistical form. And so the statistical form looks like this. As you can imagine, it's going to look mathematical. So our example here is H sub naught equals the mean of the treatment group minus the mean of the control group equals 0, right? I'll just make sure we understand that's a 0. And this is very intuitive. How do we get 0 here? It means that the treatment mean and the control mean are the same number. So the group mean for their forced expiratory volume here is the same mean forced expiratory volume here, and when you subtract the two, you get 0, which means they were the same. Means that taking the albuterol drug did not increase your ability to expire more volume. Okay, and so that's the null. That's what we would actually be testing there. Well, what is another type of research hypothesis? And, well, the other type here is the alternative. The alternative hypothesis. This is the hypothesis of some effect. We symbolize this often with just an Arabic, number afterwards, so H sub 1. Basically what we're saying here is if, I'll back that up, if null is not true, alternative must be true. Right? Remember, they're binary. Can't be simultaneously true. You can't have no effect and some effect at the same time. Again, this can be, take the written form, and the written form would look like this, H sub 1. I'll write these two different ways and then maybe just ask you what you think the difference is here. So you could say something like drug X will have an effect. You could also say something like drug X will, what's the best way to write this for you? Will have positive or negative effect. So I'll pause just for a moment here, count to 5, and just let that sink in, and maybe you can intuitively think about what is different between these two. Okay, so in this top one, drug X will have an effect. Really what we're saying is this is non-directional. Non-directional. In other words, it could be either one of these two up here, right? It can be greater than or less than. The second one is taking an either or. It's saying O1 is going to be greater than O2, i.e. it's going to be positive. So positive, right? Positive. Or it's going to be less than. And what would that look like? Or it's going to be less than O2. Or it's going to be negative. So just kind of drawing these and making the linkages here. So it could be written, and it can be non-directional, or it can be what we call a directional hypothesis. Well, if it can be written, it can also be done statistically. What on earth would that look like? Let's see, let's give an example here. H sub 1 here. The mean of the treatment group minus the mean of the control group does not equal 0. So that would be the non-directional version, kind of equivalent to the null hypothesis you see over here directly to the left. The other way that you could write this would then be directional, and you could say the mean of the treatment group is going to be greater than the mean of the control group, or the mean of the treatment group is going to be less than the mean of the control group. And essentially you set up an inequality and you make it directional. Okay, so let's just kind of wrap this section up. What have we talked about? We've talked about hypotheses, the mutual exclusivity of them, and let's just kind of end this by talking about the logic pathway. What is the logic pathway here? Well, you're holding the null hypothesis true. So what are you holding true? Let's go to a red here. You're holding this true right here. And then you're going to run a statistical analysis that is comparing whether or not this can be considered actually 0. And if the analysis indicates that the treatment group indicates that the mean of the treatment group could have been obtained by the mean of the control group, in other words, the control group was able to get to the same mean, then you're saying I have no reason to question that 0 out there. That is, in fact, could be a valid conclusion. However, if the statistical analysis is indicating that there was a very small probability that the control group could ever match the mean of the treatment group, then you'll end up rejecting the null. So the decisions at the end of the day that you'll have will be what we call fail to reject. And if you're failing to reject, you are not challenging this condition. And if you reject the null, then what you're saying is, I now am going to challenge the validity of this mathematical expression. Okay, so that is the general logic pathway for hypotheses, and that's it for this video. I hope you enjoyed it.